Good day, everyone. Let us try to solve this geometry problem. Now, we're given three circles that are externally tangent to each other, and each circle has a diameter of 1. Now, these three circles are bound together by a band. Now, the question is, what is the length of the band? Now, as you can see in the figure, the band has some straight portions. This one here, this one, and this one. Likewise, as the band binds the three circles, there's a curved part here. You have this first curved part, you have another curved part here, and then you have another curved part here. So that means if we can find the length of these curved parts and these straight parts, then we can find the length of the entire band that puts these three circles together. Now let's try to find first the measure of the straight portion of the band. In order to do that, we have to determine the point of tangency, because at the point of tangency, it is where the direction of the band changes and follows a curved path. Now, this is the point of tangency here. Now let's connect a radius. Now remember that the diameter of the circle is 1, so the radius is just equal to 1 half or zero point 0.5. Now we do the same thing here. We locate the point of tangency and then draw a radius. So we have this one here. And then when you connect these two, this one here, notice that this is a radius. This is another radius. So this length here is 1. And this length here is just equal to this one by symmetry. We do this with the other two circles. We have this one here, and we have this one. Now again, since these parts here are radius, so same thing here, this will be 1, and this will be 1 as well. Now, these parts are just equal to the straight part of the band, and since the measure is 1, then the rest of the straight part of the band is just equal to 1. Now, let's try to find the curved part. Now, for the curved part, it is on the circumference of each circle. To find the measure of this one, we need to find the angle measure in terms of radians. So we need to find the angles first. Now, as you can see, the triangle inside, the measure here is 1. This one here is 1. This one here is 1. Therefore, the triangle is equilateral. And since the triangle is equilateral, it is also equiangular, and each of the angles measures 60 degrees. Now notice that this is a rectangle here, and a rectangle has an angle of 90 degrees. So this one here, so this is 90 degrees. This is also 90 degrees, and this is 60 degrees. Now, as you can see, this angle here is a central angle that intercepts this arc here containing the curved part of the band. So, if we can find the measure of this angle here, of the central angle, convert it to radians, then that will be equal to the length of this band here. So let's try to do that. Let's find this angle here. Now, the entire part, since this is a circle, the entire measure is 360. But you have two 90s and a 60, so what remains is 120, because 360 minus 90 minus 90 minus 60 is 120. So you have 120 here, 120 here, and you have another 120 here. If you add these three 120s, that will give you 360, which is equal to one entire circle. Because again, remember, the measure of the angle of a circle is 360. So since the three portions here of the circle forms a 360-degree angle, therefore this forms an entire circle. That means the length of the band is just equal to the circumference of the circle, which is 2 pi r. Now remember that the radius of the circle is zero point 0.5 because the diameter is 1. Then we substitute the r by 1/2, so the circumference is pi. That means the length of this curved part of the band is pi. And earlier, we were able to find the measure of the straight parts of the band. That's 1, 1, and 1. So you have 3, plus again the pi, which is the measure of the curved length of the band. So the length of the entire band is 3 plus pi, and the problem is now solved. That's it for this video. Please don't forget to subscribe to our channel for more challenging geometry problems. Thank you so much. Enjoy learning.